Now that we've had the opportunity to define how we classify systems, we need to use graphs to be able to classify them, and then if there is a solution, find it. So our first problem we have here is the system of y equals x minus 3 and y equals negative 3x plus 5. So what we're going to do is we're simply going to graph each equation. So x minus 3 has a y-intercept of negative 3 and has a slope of 1. So we're going to go up 1 over 1. And I'm going to do this a few times to make sure I have a good enough number of points that I can accurately graph its intersection if there is an intersection. Then we'll go ahead and graph the other line. Y equals negative 3x plus 5 has a y-intercept of positive 5 and a slope of negative 3. So we go down 3, forward 1, down 3, forward 1, down 3, forward 1, and we draw our line. The nice part here is that I can clearly see that these two lines intersect at this point right here, which means that our system is consistent. And as you can recall, if it has one intersection point, it means it's independent. Now, a lot of people mix up independent versus dependent, but remember, independent, you are one person fending for yourself when you are independent in life. So therefore, this is going to have one solution. And if I look here, my solution is at the point 2, negative 1. So I'm going to write down 2, negative 1 is my solution. Going on to the next example. This one's pretty similar. And we have here y equals 3x plus 6. So we have positive 6. We go up 3, forward 1. I'm going to run out of room on the graph, so I'm going to go down 3, back 1, down 3, back 1, and connect my dots. And then graphing the other point, y equals 3x minus 9. So I have minus 9, and I go up 3, forward 1, up 3, forward 1, up 3, forward 1. Haven't hit the other line yet, so I'm going to keep going. And I see here that my line, as I draw it, is parallel to the other line, which means they're never going to intersect. So that means that my system is inconsistent. Now, one thing you might take note of is they both had slopes of 3. And one thing we learned last chapter with parallel and perpendicular lines is that if they have the same slope, then that means that they're going to be parallel. So if you can recognize that, then you can confirm that your graph should have parallel lines. Try one more example like this. Now we have a situation where our equations are not in slope-intercept form, which is going to make it a little bit tougher to graph. So what I'm going to do is I'm going to go ahead and solve these for y. So first I have 2x plus y equal to 3. And I'm going to subtract 2x from both sides, giving me y is equal to negative 2x plus 3. So I can go ahead and graph that. Positive 3 and down 2, forward 1, down 2, forward 1, and I'm going to keep going 2 more in either direction, and go ahead and graph. And then I'm going to solve 3x minus 2y equal to 8. By subtracting 3x, which gives me negative 2y equal to negative 3x plus 8. And then we'll divide everything by negative 2, which gives me y is equal to positive 3 halves times x minus 4. So when I go ahead and graph that, minus 4, positive 3 halves, so we go up 3 forward 2, up 3 forward 2, and since I've already crossed it, I can go ahead and draw in my line. I am going to mark again my point of intersection. I do want you to circle your points of intersection. We have one point of intersection, which makes this consistent. And independent. I'm going to abbreviate independent. And I see that my solution here again is 2, negative 1. And that would be how you would be able to graph to find your solutions.